Hi, this is Joe Macias from A Tutoring Enterprises. Today I'd like to talk about graphing exponential functions and specifically what do A and B do. Alright, well let's go over to the old Apple Grapher and get up a 2D graph and we'll start to discuss this. Alright, let's resize the window, get it in your view. There we go. Alright, today we're going to have 4 different parameters. We're going to start with A equal to 1. And we're also going to have another parameter, b, which we're going to start that at 2 rather than 1. And we'll talk about that in just a moment. 2 other parameters we're going to talk about here but not really use are h and k. We're going to set those both to 0. And then there's the star of our show, which will be y equals a times b to the x minus h. And we're going to come down and add k to the whole thing. All right. And so that's what that's going to look like. Let's go ahead and grab the axis and pull it down a little bit. You get to see a little bit more of it. And because h and k are going to be 0 here, basically I can shorten up this equation for today's video and just say y equals a times b to the x, and we can just sort of focus in on this one. It'll be the same thing. You'll notice it's right up on top of the other one. Let me turn the other one off, and we'll go ahead and start to investigate what happens when we change either a or b. And specifically, we're going to go take a look at b first. Let's go animate the parameter. It's a typical way we've been looking at a method that tells us what that parameter does. Let's go ahead and hit the settings. Now I'm actually going to kind of screw this up for you, and you'll see why in just a little bit, because exponentials are not symmetrical with respect to this particular variable. I'm going to go from 0 up to something like, I guess we can just do 4, and we'll do about 41 steps. And you'll see some of the things that I'm talking about as we hit the play button. Let's go ahead and hit the play button and you'll start to see what happens. Okay, so right now B is changing. It's going from 2 to 4, and you can see that the right half of it, the part that's greater than x, went up, and now it's coming back down. Now that's when B is 1, and this is when B is between 0 and 1. And what you'll notice is that it's going to spend a lot more time with its arm raised on the right-hand side, so to speak, compared to raising its hand on the left-hand side, which happens pretty quick. And that little flash that you saw is B being equal to 0. It doesn't like that, so it actually just sort of disappears. All right. Let me go ahead and stop this right now. And I'm going to show you a way to make it a little bit more even. What we're going to do is we're going to define a new parameter. It's not a standard parameter, but we're going to use it. It's going to be y equals, sorry, d equals 1. And what we're going to do is we're going to come over here and let b be 10 to the power of d. All right. And what we're going to do, now in effect right now what's happening is, since d is 1, this is 10 to the d, which is 10 to the 1. 10 to the 1 is basically just 10. So b right now is 10 as compared to b being 2. It's similar enough. It looks still somewhat exponential, and that's what we're going for. What we're going to do is we're going to let d just vary between, say, -4 and 4, or -2 and 2, something like that. But the point is that when we say that we're letting, let's say, for example, we let d be -2, we're going to have 10 to the -2. And what is 10 to the -2? Well, 10 to the -2, remember, we can always write as 10 to the -2 over 1. We can always write something as something over 1. In so doing, there's a rule that says that if we have 10 to, well, anything to a negative power, basically what that means is that that thing to the negative power can basically go from its relative position, that is either top or bottom, to the opposite position. So in other words, since we have 10 to the -2 on top, we can put it downstairs as 10 to the positive 2. And likewise, if this had been 10 to the positive 2, we could have brought it downstairs and written 10 to the minus 2, although that's not terribly useful for us at this moment. Now, the reason we just want to get rid of that negative sign is we want to figure out what kind of number we're really dealing with. That is, we want to deal with it as a positive 2. And we know how to deal with it as a positive 2 because as a positive 2, it means 10 squared, and 10 squared is 10 times 10. So we know that this is going to be basically 1 over 100. Okay. Now, if we had this as 10 to the negative 3, then this would be a positive 3 down here, and this would be 10 cubed, which would be 1,000. If we make this negative 1, then this is 10 to the minus, or 10 to the 1, positive 1 down here, and this will be 1/10. So you can see that what we're doing is as we change d by 1, we end up changing b by various powers of 10. And that's actually going to help it even out. All right. Likewise, when we get to 10 to the 0, when d becomes 0, we'll have 10 to the 0. Does anyone know what 10 to the 0 is? If you're not sure, if you're saying that it's 0, you better go check your calculators. 10 to the 0 is 1. Okay? And 10 to the first is going to be 10. 10 to the second is going to be 100. 10 to the third, 1,000, and so on down the line. All right? So it's not going to really like this. I'm just going to hit OK, and then we'll just delete this. But our goal now is just to go ahead and let d vary. So let's go ahead and animate this. And we're going to go ahead and change it from -2 to 2, and we'll still go by 41 steps. All right. What you'll see is now it should spend the same amount of time with its arm raised on the left-hand side as on the right-hand side. And we've also eliminated the letting b go to 0. B becomes a very small number as d becomes -2, but it doesn't become a very big, it doesn't go to 0. So, all right, now that we've got our variable b set to doing what we want, we can see it's spending about the same amount of time on the left as it is on the right. What is going on here? What can we say is happening? Well, one of the things we can say is happening is this thing is oscillating about this particular point right here. What is this point? Well, that point is 0, 1. And it makes sense because when you put in 0, remember we're really looking at this equation, when you put in 0, no matter what b is, no matter what we make it, anything to the 0 ends up being 1. In fact, you just hopefully check that out on the calculator. When I told you 10 to the 0, 10 to the 0 is not 0, it's 1. 11 to the 0 is 1. 2 to the 0 is 1. 1/2 to the 0 is 1. And so that's why this point is staying where it is, because that's the one place where we always get something to the 0 is 1. Okay. All right. The other thing you could say characteristically about this graph is that as we take the absolute value of d, that is as b is either approaching 0 or going to infinity, those are the sort of the two choices, it becomes more box-like. Let's go ahead and click on d. So now d is becoming like -2. It's going towards -2 means that it's going to 10 to the -2, 10 to the -3, 10 to the -4. So as it goes in that direction, b is getting closer and closer to 0, and you can see it's very much more box-like than if we let it move here. It's more rounded. Okay. And then it's going to become flat as we let b equal 0, and then it's going to go the other direction. Again, it's becoming more box-like as d is approaching a bigger number on the positive side. So if we think about the absolute value of d, as d becomes bigger and bigger and bigger, basically this thing becomes more box-like, or at least corner-like. I guess it's not a true box because it doesn't have two sides to it, it's just the one side. The other thing that we can say is the difference between what's happening right now and what's happening right now. This is called a decay function. It decreases as we move to the right. Okay. Often the x variable will be time. And as we move forward in time, we would picture this going this way. So this is a growth function. This is a decay function. And so b is picking out which of those it is. Decay growth. All right, now even though the transition is pretty smooth and it's pretty obvious that this is a value that, I mean, typically there's no problem with letting d be 0, and if d is 0, 10 to the 0 is 1. We're letting b equal 1. b equals 1 is the boundary value, if you will, between the decay and the growth functions. Clearly, it is neither a decay or a growth, and in fact, very specifically, this is one that would not be called an exponential function. We could see it's in the array of our values of b, and it actually makes sense to sort of put it in there, but to call it an exponential function itself, letting b equal 1 and calling that an exponential function is not quite correct, and certainly the books make a big deal of saying that you shouldn't let b equal 1 and call it an exponential function. Clearly what we've got here is a straight line because, if this is 1, then basically this is y equals a, and right now a is equal to 1, so you're looking at y equals 1. Okay, just a straight linear equation. All right, so we've taken a look, hard look at what b does, and we know it controls a few properties, whether it's going to be exponential growth or exponential decay. We also know that it affects how box-like or how corner-like the function ends up being. So given those two, let's go ahead now and look at what happens to a in this function. That got re-clipped as soon as we played with d, and it's going to do it again when I parameterize a. But good. It's right now it's just right on top of the other equation, so it really doesn't matter. Oh, got to stop the. Well, that's what happens if you try to parameterize a second one. You can't do it. Got to stop the old one. So I guess every time I screw up and do little things like that, you learn something too, right? Don't do that. All right, so we're going to animate the parameter a, and we're going to see what happens when we do this. Let's go see what values we've got. Let's go from negative, let's go negative 4 to 2. Let's do that. All right. Even though that's a little not symmetric, this is what a is doing. Here a is negative. So in effect, letting a be negative flips the graph effectively about the x-axis, and letting a be positive, it does that. Oh, there was one other, sorry, let me pause this for a moment. There was one other parameter, or I shouldn't say parameter, but feature of the graph that we really didn't discuss, and that was y equals k. Now, y equals k, right now, because k is equal to 0, is just this line at the x-axis. In fact, so we can't even see it because k is 0. If I go ahead and make it red, that's going to make it visible. But typically we want to think of this as a dashed line. The dashed line is just sort of a line that's not really part of the graph, except what it does is it tells us that this curve is approaching, as if we were to go to the left, in this case, as we go towards the left, this curve approaches the dashed line. The black line approaches the dashed line. Now, I know over here it looks like it's the exact same line, but if you were to zoom in on that, you'd find out that the black line still is a little bit above y equals 0, about, above the dashed line. And it's going to be that way no matter how far you go to the left. That's the really amazing thing. Now, the further you go to the left, the more you're going to have to zoom in to see it. But you can do it. I'm not going to spend time doing it just because, well, it's something you can explore. If you think I'm wrong, by all means, make a little video showing me I'm wrong, but I'm going to come back with a video showing you I'm right. So make sure you're doing it right. Okay, so that's what's happening. This is what we call an asymptote, and asymptotes are really, to some extent, a visual representation of something we're going to talk about later in pre-calc and calc, which is a limit. In essence, as x goes towards negative infinity here for the function, the y value approaches 0. It'll never actually get to it, but it'll get close to it. And in a sense, when we take what's called a limit, that's where mathematically we go around and finally say, oh, okay, it's 0. We'll say that if we go far enough to infinity, we'll call it 0. And that, in effect, is what a mathematical limit is doing. All right. So I was discussing A, and I wanted to take a a little look at A. Now, as I play this, let me play it again. I want you to notice nothing happens to the horizontal asymptote. It stays exactly where it is, and that is because, remember, this is a stretch. I'm claiming that this is a stretch in the y direction, so if you stretch something from y equals 0, well, nothing happens to it. It stays at y equals 0. All right, let's just kind of pick out some values here and take a look. Now, when y was equal to 1, let me get there. Oh, I picked a bad value. Okay, I'm sorry. Let's go ahead and pick this to be 4 then. That'll even it out. And there we are at 1. Okay, when a is equal to 1, basically we've got y equals b to the x. And right now, we got d equal to 1. If d is 1, this is 10 to the 1. b is 10. And that really makes no difference because when we put 10 in there, we're looking at x equals 0, so 10 to the 0 will be 1. So 1 times 1 is 1. So that's where we're at right there. But if I now go ahead and let a equal 2, that b to the 0, oops, went past it, that b to the 0 is still 10 to the 0, and that's still 1. And so now we're taking 1 times the a value, but the a value is now 2. So we're now at 2, 0. So what we've done is we've stretched this distance from 0 to 1, and we've doubled it from 0 to 2. If we make it 4, let's jump all the way up to 4, we've now stretched it from 0 to 1 to 0 to 4. Okay. And if we make it negative, well, I guess we don't have, let me move this up here, and I make it negative 2, well, first of all, negative 1, that's just now screwing up because I moved the screen. That program does this sometimes. Let's see if I can, hopefully that'll work better. Sometimes when, this is the old version of Grapher, and sometimes when you move the screen around, the graph screws up, and sometimes you just have to save it and then bring it back in. If that occurs, you got an old version of Grapher, then that's the solution to it. Hopefully the newer versions don't do this. I don't know if they do or they don't. If they are, well then that again is perhaps the solution. Save the graph, quit Grapher, then bring it back up, and hopefully that problem will be solved. Okay, so with a being negative 1, basically it's just been flipped about the x-axis. From where it was originally going like this, it's now doing the opposite, going like this. And if I now make a negative 2, there it was, and again it appears to be off, there we go, we're going to have this distance now being twice what it was previously. Previously it was like this. Okay. So this is probably a good place to stop because the grapher is deciding to not do things like it should do it, and so if I don't touch it anymore, it won't break. And that'll be fine. So let's go over to the last screen. The next video we're going to talk about changing h and k. So we'll do that in the next video, and that's probably a good idea since it's already starting to act up here. I'm going to go ahead and save this and quit it and come back. All right. So back to the final screens. We were studying exponential functions. We were interested in what a and b were doing, and we took a look at that. I'm from A Tutoring Enterprises. That's my business. My name's Joe. There's my website, my email, my phone number. I do online and in-person tutoring, both in physics, chemistry, and engineering. And if you need some help, give me a call or shoot me an email. We'll get you an appointment and try to help you. If you like the video, no, don't hit the unlike button or the I don't like button. Please hit the like button. It's just April Fool's. It's a joke. Don't take it too seriously. It's April Fool's Day, 2013. So maybe if you're watching this 2 years later, hopefully you are. Somebody is. All right. If you enjoyed the video and it helped you, then maybe you might send me $1 to my PayPal account. Just add a little shareware to the brain, help me out, and I can increase my technology here and help you guys out in the end run. And then let's get to the white screen where we're going to have links to the previous videos and the next videos and things like that. There's not going to be a whole lot of links here, but some that will go to the exponentials, and then you might have a couple to the quadratics and the linears and things like that, just so you can kind of keep in touch with those. And that's about it. I hope you liked it. I hope you get a chance to look at the next one coming up, which is H and K. And thanks for viewing this one.